Congratulations, you've made it to the last part of week 1. We're going to look at applications of parabolas. Why do we need to learn about parabolas? What good do they do us? So let's talk sports. You are going outside to practice kicking a football. The graph below represents the relationship between the height in feet and the horizontal distance, also in feet, of the football after you kick it. Use the graph to answer the questions below. So our starting point, which happens to be at 0, 0, is where the player is kicking the football. The path of the football mirrors that of a parabola. Question number 1, when the ball lands, how far is it from the starting point? Let's first find where it lands on the graph. Here is the point where the ball lands. So the question asks, how far is it from the starting point? 55, and our label, 55, and our label are units of feet. Question number 2, what is the maximum height achieved by the ball? The maximum height occurs at our vertex. The coordinates of my vertex, as I go down to my x coordinate, it's halfway between 25 and 30, which would be 27.5, and the y coordinate corresponds with 20. So the question says, what is the maximum height achieved by the ball? So do I want the x value or the y value of my vertex? And the answer is the y value. So my max height is 20 feet. Question number 3 asks, what is the domain of this situation? In general, for parabolas, the domain was all real numbers. But my parabola doesn't have arrows on it. Now I'm talking specifics for this situation. Domain is our x value. So as I look at the far left point and the far right point, I want those to correspond with my x values of 0 and 55. So I'm going to write that as an inequality. My domain would be 0. My mouse doesn't want to cooperate. Less than or equal to my domain, that goes with x values, which are less than or equal to 55. That was the maximum x value. Now let's look at range. Range is my y values. Okay, these are my low points, and my vertex is my high point. So my graph goes from 0 to 20 for a height in feet. So to write that as an inequality, 0 less than or equal to y less than or equal to 20 feet. If a player is standing directly under the ball when the ball reaches a height of 8, how many times does this happen? So I want to know, how many times does the ball reach a height of 8? I can see that it happens right here and right here as the football goes up in the air and as the football goes down in the air. Okay, so where that's happening then is halfway between 5 and 10 and halfway between 45 and 50. So halfway between 5 and 10 is 7.5 feet, and halfway between 45 and 50 is 47.5 feet. Number 6, if another player comes on the field and catches the ball 47.5 feet from the starting point, how high would he or she have to jump to catch it? Well, we kind of actually already answered that in our last question. So how high would they have to jump? That would be a height of 8 feet. If a third player comes on the field, would he or she be able to intercept the ball that is in the air 20 feet from the starting point? 20 feet from the starting point. Yeah. How? Could they? Could they jump to get to 18 feet? Do you think they can intercept the ball at 18 feet? That would take a miracle. So the answer is no, unless they are a giant. Let's take a look at the last page for the week. You and your friend are standing on opposite sides of the room playing underhand catch with a tennis ball. Draw a diagram of what the path of the ball would look like to the right. As a reminder, I'm not an artist. So you and your friend, beautiful, I know, are playing underhand catch with the ball. So I'm going to toss the ball up, and my friend's going to catch it. And then the same thing going back. So the path of my ball makes that of a part of a parabola. It turns out that there is an equation relating the time the ball is in the air and the height the ball reaches. The equation is given by h equals negative t squared plus 6t. Fill out the chart below. The chart has been set up beautifully for us, so we're going to take a look at the time in seconds at 0 second, 1 second, all the way up through 6 seconds actually. We're going to plug that number into our equation. So let's plug 0 in. Order of operations, make those look like a 0. I do exponents first. 0 squared is 0. The opposite of 0 is still just 0. 6 times 0 is 0. 0 plus 0 is 0. So at time 0, my ball is 0 feet high, which would make sense. It's in my hand. At 1 second, 1 squared is 1. The opposite of that would be negative 1. 6 times 1 is 6. Negative 1 plus 6 is 5. So at 1 second, the ball is 5 feet in the air. Please hit pause and complete the rest of the table. Do your values match my values? At 2 seconds, it is 8 feet. 3 seconds, it is 9 feet. Then it starts to make its way back down. At 4 seconds, it is 8 feet. 5 seconds, it is 5 feet. 6 seconds, it is 0 feet. Let's complete the graph. They've asked us to label the x-axis with time and the y-axis with height. So our x-axis is time. And what are we measuring time in? We are measuring it in seconds. The y-axis is our height. We are measuring our height in feet. My numbers that are in my table are small enough I can go by ones on both the x-axis and the y-axis. Now let's plot our points. 0, 0, 1, 5, 2, 8, 3, 9, 4, 8, 5, 5, and 6, 0. Let's connect the points. Let's use our graph and our table to answer the questions below. How long does it take for the tennis ball to hit the ground? It is hitting the ground right here. So that is after a time of 6 seconds. what is the maximum height achieved by the ball? Anytime we're talking about maximum or minimum, we're going to be talking about the vertex. Okay, the vertex of my graph we found had the coordinates of 3, 9. So the maximum height is 9 feet, and that occurs at 3 seconds. Make sure you are labeling your answers. How high is the ball after 1 second? We can refer to either the graph or our table. After 1 second, our graph, or the ball, is 5 feet high. How about after 4 seconds? I can look at the graph or my table to see the ball is 8 feet high. When is the ball at a height of 4 feet above the starting point? When is the ball at a height of 4 feet from the starting point? So 4 feet occurs right here. So as I look at the 4-foot line, it's occurring twice, right there on the way up and right there on the way down. So that happens somewhere between 0 and 1 second. Okay, it looks to be about halfway. So let's say 0.5 seconds is one of them. And then the other one, I've got to take a look at where it's coming down. That occurs between 5 and 6, and it looks pretty close to halfway also. So let's estimate 5.5 seconds. Question number 5, what is the domain of the situation? Domain goes with our x value. Okay, as you can see, our table went from 0 to 6. Those are my x values that I used here. So my domain is 0 less than or equal to, I know domain goes with x, but in this case it goes with time. So I'm going to put a t in there for time, less than or equal to 6. My range is my y values. Okay, my graph goes all the way up to 9. That's my high point. And 0 is my low point. My ball doesn't go below ground. So 0 less than or equal to, I'm going to put h for height, less than or equal to 9.